Hello everyone, today we will be going through a first-hand investigation where we will be testing the pH of a variety of solutions. So the aim of the experiment is going to be to test the acidity or basicity and the pH of a range of different solutions. So to test for the acidity and basicity, we use three different equipment. We'll be using universal indicator, different indicators, and also a pH meter and pH electrode. And in school, when you're doing the experiment, you'll be using all three of these. Universal indicator. This type of indicator paper produces a range of colors that can be matched to the standard card. So this is the standard color card, and a pH of less than 7 would give you a color of a red to orange, so red to yellow, and then neutral will be green, and the purple colors show alkali. So if a base is tested, it would produce a purple color. Now this is a parameter, so you can see that it's from 1 to 14 and it produces different colors. Different indicators cover a whole range. So other than using just universal indicators, we will be using more than one indicator, and this way we can narrow down the range of the pH. So for example, indicators such as phenolphthalein can be used. Look at this table here. There are a range of indicators we can use. For example, methyl orange, methyl red, bromothermal blue, phenolphthalein, and alizarin yellow. So for example, if we're going to test for water, distilled water, we'll be using methyl red and phenolphthalein. When we use methyl red, we would get a yellow color because it is going to be greater than 6.2. The pH of distilled water is greater than 6.2, so we would get yellow. And phenolphthalein would turn colorless because the pH is less than 8.2. This way, we know that the pH is going to be between 6.2 and 8.2. And that's how different indicators work. And you would narrow down the range by using more. Moving on to the next one now is a pH meter and pH electrode. This system uses galvanic cells to measure the electric potential differences across the glass membrane of the pH electrode. So the main thing to remember is pH meters and pH electrodes use electrical potential differences to measure. The differences in voltage are related to the pH. So what happens is the voltage differences would reflect the changes in pH. The pH probe and meter must first be calibrated with solutions of known pH. So for example, you would use distilled water at room temperature, that is 25 degrees Celsius, to calibrate it to 7 so that your pH probe or meter is calibrated before using. And this is a step that you should take before you do your experiment. This is the simplest and the most accurate method. It gives you a pH reading to 1 decimal place, which is quite accurate compared to the other methods. Now, when you're doing this experiment, you would have few solutions which you'll be testing. As acidic solutions, you'll be testing hydrochloric acid, vinegar, lemonade, lemon juice, and milk. As you can see, these three are household products, while this is a chemical. So this way you can compare how the 5 substances have varying pHs. You'll be also testing for basic solutions such as sodium hydroxide, baking soda solution, ammonia solution, chlorine bleach. Now the method. When you're writing the method, before you write the method, you should always include a risk assessment. And this is very important, especially in this topic, because acidic environment is using acids, and acids are very corrosive and caustic, and safety glasses and gloves should always be worn. So this safety risk assessment would say, although these solutions are weak, precautions must be taken to get the solutions on, not to get the solutions on your hands or clothes. They are still corrosive and caustic, and safety glasses must be worn. So this clearly shows the risk assessment, and it tells you why it's dangerous and also how to prevent you from danger. Then you would write down your method in step-by-step form. So first, test the given solutions with 3 different pH testing equipment. So what we did was we used universal indicator, different indicators, and also a pH probe. And record all the observations, color changes, and the pH values in a table. So tables are easy to read and they're great ways of showing your results. So this is a table, and this is what your results table should look like when you do it at school. So we have pH and solution. The pH should have the corresponding solution next to it. So this table has HCl, vinegar, lemon juice, lemonade, milk, baking soda solution, ammonia solution, and chlorine bleach, which is NaOH. And it has the corresponding pHs right next to it. It's very neat, and it's also much more clearer when you're discussing your results. Accuracy and reliability, and these are 2 words that you should always mention in your experimental report. The results obtained will vary, especially with commercial products, due to normal differences in composition of the material selected. Now what they've done is to give an explanation for why there might be changes between 2 different indicators or 2 different commercial products. And this is to show that your accuracy might be a bit decreased due to the differences in the composition of materials and the fact that you use commercial products such as milk. Reliability can be improved by repeating the measurements to obtain consistent results. Now this would wrap up our experiment, and we wrote a very comprehensive report here. So when you do this at school, it will be much more easier for you, and also you would understand how they work. At school you would get a more practical hands-on experience. Now we'll go to some questions, because questions do come in the HSC regarding experiments. Question 1. Question 16. When using pH meters or probes to determine the acidity, basicity of chemicals, you can increase your reliability in a number of ways. Which technique would improve the reliability of the experimental results? Here you should underline reliability, because that's a key word. Now we know that reliability can be increased by repeating. We'll consider the options we have. Option A, calibrating your pH meter or probe with standard solutions before using. Now this is a very good practice, but it is not to increase the reliability. It is to increase the accuracy. So this is not the answer. Option B, comparing your results with published results. Again, this is a very good practice before you hand in your report, but this is to increase validity, not reliability. Option D, comparing your hypothesis with that of other students does not improve the reliability. Option C, reliability can be improved by repeating the measurements to attain consistent results. Therefore, the answer is option C, repeating the measurements several times. Moving on to question 17 now. You carried out a first-hand investigation to use pH meters and probes and indicators to distinguish between acidic, basic, and neutral chemicals. Describe the method you used. Now this can be a very popular HSC question, and this is to wrap up the method you used for the experiment we just did. Now with this method, it should be comprehensive if it's a higher marker question, but if it's a 2-marker question, it could be brief and specific. So you would write, you may have set up a series of beakers, each containing solutions of lab chemicals such as HCl, sulfuric acid, NaCl, Na2CO3, sodium hydrogen carbonate, and ammonium hydroxide. As you can see, you should name the chemicals because that way it shows that you know your stuff and also that you are more specific with your ranges of the chemicals you use. Or you could use household items such as orange juice, detergent, drain cleaner, tap water, rainwater, liquid soap, and alcohol. So you may have used some of these in your experiment at school. The probe would be placed in each solution in turn to measure the pH, washing it after testing each solution to avoid contamination. This would tell you what the method you did, so how you measured your pH using a probe. And that's how you would go about answering question 17. Moving to question 18 now, outline any advantage of using a pH meter or a probe instead of an indicator such as methyl orange or phenolphthalein. As you can see, as we went through, a pH meter and a probe would give you a greater accuracy. So you would mention that pH meter or probe is more accurate. It provides an actual pH reading and gives you a pH reading to 1 decimal place, while indicators only give a range within which the pH falls. So again, this is more accurate and it gives a very specific reading. Now wrapping up what we did this lesson, we went through an experiment that reflected how you can test pH of different solutions, and also we saw the basicity and acidity of household substances. During this topic of acidity and pH, we talked about how acids and bases react in water and also described what pH is and how pH varies and how you can find the pH with the hydrogen ion concentration.